Hi, everyone. In this video, we're going to look at a tool called the mole that we used in chemistry. Now, unfortunately, the mole is not just this cute little critter doing chemistry, but rather it's a way that we count the very large numbers of atoms and molecules that we encounter in doing some of our calculations. And so the chemist's way of counting, or the counting unit that we use, is the mole, which represents the number 6.02 times 10 to the 23rd. It's called Avogadro's number. And we have to use a number like this because we have to remember just how tiny an atom really is. And it's useful for us to think in terms of a single atom or single molecules when we're picturing the structure or the shape, or if we are talking about what happens in a chemical reaction, as we'll be discussing in another video. But anytime that we start to talk about sort of real world reactions and we start to talk about the amounts of things in a chemical reaction, we need a way to drastically scale that up, because it doesn't do us any good to think about a single molecule reacting if we're looking at the actual amount involved. And so that's where the mole comes in. Now, it's important to remember here that the mole is quite often a rather confusing concept for people, but it's important to remember that it really is just another counting number. And so if I were to tell you that you have 1 dozen of anything, you know that you have 12 of that thing. If you have 1 gross, if you haven't seen that term before, that's just 144. A gross of anything is simply a dozen of that thing, and so on. These are just words that stand for a certain specific number. It's the same with a mole. If I have a mole of something, usually abbreviated MOL, by the way, I know, big abbreviation there. But if you have a mole of something, you have 6.02 times 10 to the 23rd of that thing. Sloppily written too, and this one's not much better. Sorry. But that's all it is if you have a mole of something, you have 6.02 times 10 to the 23rd of whatever it is that we're working with. For our purposes, it's usually going to be things like atoms or molecules. And so think back as well to when we talked about dimensional analysis. I thought, yeah, it's right here. I thought I had it on this slide. This is just a conversion factor, just like any other that we looked at. And so if we can convert back and forth between the number of atoms or molecules and the number of moles. I want to really get rid of that S that I have there. Oh, okay, that's gonna bug me. There we go. 6.02 times 10 to the 23rd atoms or molecules per mole. And so, for instance, if I tell you that we have, we'll just make up any example here, 2.53 times 10 to the 24th atoms of iron, and we want to know how many moles that is. It's just a simple conversion factor. We take our 2.53 times 10 to the 24th atoms. We know, and in this case, we want to be left with moles and we want atoms to cancel. So we're going to set up Avogadro's number in our conversion like this. And then we put that into the calculator and it gives us whatever it gives us. I'm not going to do that out, but 2.53 times 10 to the 24th divided by 6.02 times 10 to the 23rd. Actually, I will point something out. So this is as good time as any to talk about calculator usage. And it's very important when you're using scientific notation. I don't think I talked about this when I talked about scientific notation, but it's very important to use the EE button on your scientific calculators. If you have a TI like this, the EE is above the comma. You can see it right there. So you would hit second. Try to do this in the mirror. There we go. Second, and then the EE button. And the way that you would type these in would be 2.53, and then you would type EE 24. that EE takes the entire place of times 10, and then your exponent comes in. That's so the calculator keys in on the fact that you're doing scientific notation. If you don't do that, especially in cases of division like this one, if you don't use this EE button and you don't use parentheses very carefully, the calculator is going to see this as a different sort of calculation. What the calculator will do, so we had 2.53, just to show you an example. If you just put this into the calculator like this, 2.53, and then you do multiplication symbol times 10, caret 24, and then you do your division symbol. So again, if you're literally just putting it into the calculator like this, 6.02 times 10, caret 23. So if you type it in there like this, what the calculator is going to do is it's going to do this one first, perfectly appropriately. But then it's going to divide by 6.02, then it's going to multiply that whole answer times 10 to the 23rd, and you'll get wrong answers. Now, yes, you could correct for that by putting parentheses around this whole thing, and that should probably take care of it for you if you're inputting everything else carefully. But that's the whole point of the EE button, is it tells the calculator that this is a case of scientific notation and that this is equivalent to this number. Then divided by 6.02, and this is equivalent to this number. And so be very careful with that. So like I said, on the TIs, it's just right there above the comma. So you would do 6.02, second E23. See if I can show you what it would look like. There you go. So you can see it right there. So that's what it would look like in the TI calculator. And so depending on what type of calculator you're using, you'll just want to make sure that you use that appropriately. A calculator on your computer, you would want to make sure that you're viewing the scientific rather than the basic. The basic doesn't give you this option, but the scientific does. And so then 6.02 E23. So just make sure that you are using that, because if you're not, you might set everything up correctly, but you might end up with wrong answers because the calculator is so strict in the way they follow their order of operations. So just make sure that you're making note of that. But anyway, so like I said, so we can use Avogadro's number as a conversion factor. Let's say we're going the other way. If you're told that we have 1.6 moles of glucose molecules, and we want to know how many actual molecules that is. So we're going to go our 1.6 moles. This time I want moles to cancel out, and I want to be left with our number of molecules. So I'm going to go 6.02 times 10 to the 23rd up top. 1 mole, there's my Avogadro's number. So remember, this is our Avogadro's number conversion factor. And we plug that in and get whatever we get. So it's just a conversion factor for us. The other way that we're going to use moles is, remember when I talked about atomic mass back a couple videos ago, we used units that were kind of meaningless for us, but they were units of AMUs, just a sort of a generic atomic mass unit. Now, instead, what we're going to use are units of grams per mole, because that's really what atomic mass is. The atomic mass of an element tells us how many grams are in 1 mole of that element. Very useful conversion factor for us. Yep, there we go. This is what I want. And so that's a very useful way for us to convert back and forth between grams and moles of atoms or molecules. To find the molar mass of a molecule, we simply add up all the molar masses of the elements involved. And so if I want the molar mass of NaCl, I get out my periodic table and I see that Na has a molar mass of 22.99. Cl has a molar mass of 35.43. I add those up. and I get a molar mass of NaCl of 58.42. So that's my molar mass of sodium chloride. Make sure that you multiply by however many of each atom you have. And so if I have MgCl2, then Mg, I only have one of. The molar mass of magnesium, 24.31. Cl, I have 2 now, times my 35.43. And so 2 times 35.43, 70.86. And so that added to my 24.31 gives me a molar mass of magnesium chloride of 95.17. Let's just do one more example. Molar mass of glucose, C6H12O6. So carbon, I have 6 times 12.01. Hydrogen, I have 12 times 1 point, we'll call that 0.1. Oxygen, 6 times 15.99. And so it would depend on what type of calculator you're using or how you want to do this. You could either do each of these out individually or put it into the calculator at the same time, however you wanted to do that. I'm going to do just on my calculator, 6 times 12.01 plus 12 times 1.01 times plus 6 times 15.99, and I get a molar mass of glucose of 180.12. And that's 180.12 grams per mole. And so take a look again at what this is. So the molar mass in units of, I'll write it even a little bit differently. That's just another conversion factor. And so it's the conversion factor that we're going to use now for atoms or molecules, converting back and forth between grams and moles. As we'll see in, I think it's probably the next video that I'm going to do, this is a very, very, very useful conversion that we're going to use a lot in converting back and forth between the grams of a substance and the number of moles of that substance. So we'll use this for a lot of different conversions. And so again, to throw an example out there, so if I have maybe 3.2 moles of glucose, and I want to know how many grams that is, then it's just my conversion factor of 180.12 grams times my number of moles. I put that into my calculator, I get whatever I get. I'm going the other way. Let's say I have 72.3 grams of glucose. Now I'm just going to set my conversion factor up differently so that my grams cancels out. I'm left with moles. I'm going to take 72.3 divided by 180.12. And whatever that gives me for a number, that would be the number of moles of glucose that I have. And so you can do these calculations in a couple different ways. You can either set up things by dimensional analysis, or you can remember this flow chart that I put together as well. Actually, I'll admit I blatantly stole this one. But we'll see that moles is central. And so if we're trying to go from atoms or molecules, if we know the number of atoms or molecules and we want to know the number of moles, then we're going to divide by Avogadro's number. If we know the number of moles and we want to go to atoms or molecules, then we're going to multiply by Avogadro's number. Same over here with molar mass. If I know the number of moles, I'm going to multiply that by the molar mass to get to the number of grams. If I know the number of grams, I'm going to divide by my molar mass, to get to the number of moles. And you could do these in 2 different steps. Let's say, we'll stick with glucose. If you have, I don't know, 100, we'll say 121 grams, grams of glucose. And we want to know how many molecules of glucose that is. We're just going to set up both calculations right at once. Sorry, writing very sloppy today. But first we're going to convert over to moles. And so all I'm doing here is I'm starting with grams and I'm gonna convert over to moles. So I'm gonna divide by the molar mass, my 180.12 grams, 1 mole. And then I want to get to the number of atoms or molecules. Now I'm going to multiply by Avogadro's number. Sorry, let me do this. We have both up at the same time. There we go. And so we can see how, using dimensional analysis, our grams cancel out, our moles cancels out. I'm left with the number of molecules, which is what I wanted. We'll actually do this one out. We get 121 divided by 180.12 times 6.02 times 10 to the 23rd. And I see that I have 4.04 times 10 to the 23rd molecules of, wow, glucose. And so that's how we use the mole. We're going to be using it a fair bit in I think just the very next video that I do, which I will actually be starting off with that slide. So I'm not going to go there quite yet. And so that's it for our video on the mole. I hope you enjoyed watching it as much as I enjoyed producing it. And as always, you stay classy, USM.